Find the limit as x approaches infinity of x squared times e to the negative x power. All right, so the first thing we should do here is to just go ahead and plug in infinity here, right? So once we do so, what do we get? We get infinity squared. Okay, remember, infinity squared is also just infinity. And then, wait a minute, e to the negative infinity, right? Well, e to the negative really large number. Okay, remember, this is just an exponential function. So this is just equal to actually just 0, right? So we end up with infinity times 0. Now this is an indeterminate form, right? So we can use L'Hopital's rule here, but right, the problem here is L'Hopital's rule only applies in the fractional form, right? We would take the derivative of the numerator and then take the derivative of the denominator. Well, wait a minute, there is no numerator and denominator here, okay? So we have to do some type of algebraic manipulation here. And right, we know that x squared, right, we can write that as 1 over x squared, right? So we can really bring this down as a denominator of a denominator, right? But we don't want to do that here because, for example, we end up with e to negative x all over 1 over x squared, okay? So remember, this is equivalent to this, but this really doesn't get us anywhere, right? But take a look at, right? Wait, e to negative x, right? This is actually a lot easier than it looks, right? We can just bring that e to negative x down to the denominator. So we'll take the limit as x approaches infinity of x squared over e to the positive x power. And take a look at what happens here, right? When you plug in infinity, well, wait a minute, I get infinity squared, which is, once again, just infinity. And e to the positive infinity now, right? E to the infinity, that's just an exponential function. That keeps shooting up, right? We get infinity over infinity. That is another indeterminate form. So that tells us, hey, I have this fraction now. Now I can use L'Hopital's rule, right? Let's try it once. We get limit x approaches infinity. Okay, the derivative of x squared is 2x. The derivative of e to the x is just e to the x power. And when I plug in infinity, right, I get 2 times infinity, which once again is just infinity, and we get infinity down here, right? Another indeterminate form. So let's do it one more time. It looks like, right? Limit as x approaches infinity. The derivative of 2x, wait a minute, that's just 2. The derivative of e to the x is e to the x again, right? So what happens? We get 2 over infinity, right? Well, that's just going to be some really, remember, we're taking the limit, right? So the limit as x approaches infinity of this guy is, well, 2 over some really big number, right? That's just really close to 0. So the limit of this function is going to equal 0.